IBM quantum computer simulator software, Qiskit, is installed in the RAD cluster. I'm going to show how to use the Qiskit simulator to write your quantum program in the RAD cluster. This is what it looks like, a real IBM quantum computer. It's like a tube. It's in the very low temperature. The inside structure is more like a chandelier, so many tubes, totally different from the traditional computer. At this moment, we are not going to run our code in the real quantum computer. We are going to use this Qiskit simulator to write program. After you tested your program, you can upload into the IBM, the real quantum machine to run your program. In the later, I'm going to create a video to show how to create an account in the IBM quantum computer. This is the official website of the Qiskit. You can find all the documentations, tutorials, programming APIs from this website. The Qiskit is Python-based programming environment. We already installed Qiskit software and the IDE for programming environment Jupyter into RAD cluster. This is the official website. You can find the documentation for the Jupyter in here. Also, this is the graphic interface. So if you want to run the Jupyter notebook and you need to install the Xmin into your laptop to serve as X window. I'm going to have another video to show how to install Xwin. Before you SSH into a RAD cluster, you need to make sure to run the Xwin in your laptop. Xwin is I'm installed at my desktop here. To click this one, Xwin, it's in the background. You will see from the task panel, you will see this X. So that means X window is up and running. And then within your party, you need to set up this SSH to enable X11. Just simply make a check mark at here. After you make check mark, you save it. So in this way, the X11 are enabled in your SSH. So let's log into a user account. Okay, the first step, you need to make sure your Python environment. So you need load Encarta module. Okay, after you load Encarta module, the Python environment is loaded. After that, you can run Jupyter notebook % that is running on the background. Okay, after second, you see this web browser window environment is bring up to your desktop. Probably you want to create a new folder. For example, you can create a new folder at here. This is your home directory that is in the cluster, RAD cluster home directory. Within the home directory, you create this new folder that is place you can save all your quantum program in this folder. A next step is going to create a new Python 3. This is Python 3 program within the Jupyter notebook. From here, you can write your code. Let's find. This is the Qiskit official webpage. You see here is an open source documentation. From here has a tutorial circuit. This is a circuit visualization, so we can go to the tutorial circuit to get started with Qiskit. You see here has this example to create quantum circuit. Let's do this one as an example. And here, for example, we are going to import NumPy as NP. Hold your Shift key to enter. That's going to get into another line. If you want to type into all this into one line, you're going to just simply hit enter. Import Qiskit, import everything, define variable. So you can draw a plot graphic in line Okay, this is the first statement. Okay, the next line, we can create a circuit. Circuit is going to quantum circuit. We are going to create 3 qubit. Okay, shift. You also can run this one. So it's a line by line. I have to run this one, and then here has no error. This 3 qubit created. The next step, head market to put a 0. That means put this qubit at superposition. Here has the detailed description. After we put qubit 0 into superposition, and then we can create another CX, means the same as the normal program if statement. Is a condition not operator. Okay, condition not operator. And then we are going to put 0 and 1 qubit in the entangled. Okay. Also, we are going to C0 our first qubit to the second bit entanglement also. And then you can visualize to see what is look like. Just draw the circuit. Qubit 0, we put in the head market, so that is put into a superposition. We put C0, make a first one and the second one entangled. And also put 0 and 2 also entangled. Another better way draw, you can use more graphic style. You see, it is actually the same thing. Okay, all this documentation is very useful. For example, here has the description. We create 3 qubit, and after we create this, after you measure the quantum bit, it's going to collapse, and then you cannot reverse. At this moment is the superposition. You really don't know what is 0 and 1 in the both. This is just a very basic example how to use Qiskit to write quantum gate. There are so many tutorial examples. Also, you can find very detailed what is our terminologies. Okay, I'm stopped at here.